This teacher education presentation will focus on the process of instruction for multi-digit multiplication. We will focus mainly on the lattice method and the partial products method. First, I will quickly review the background of the multiplication process. It is important to establish a definition of multiplication before we begin any discussion on how it should be taught. I found the definition that multiplication is repeated addition. Our corresponding graphic visualizes this as well. Multiplication is a more streamlined, efficient way of joining multiple add-ins of the same quantity. I think we should make an effort of imparting this definition to our students when we begin teaching multiplication. Our students cannot learn the process effectively if they do not know what multiplication is. In my personal student experience, multiplication was taught as something we had to memorize. Every week, we would be given a certain times table, starting with the ones, then the twos, and so on, and we're told to memorize it for a quiz on Friday. I do not remember any explanation of what this was all for and where these numbers came from. The standard algorithm, which we will go over later, was taught in the same way. The lessons carried the message, "This is what you do," instead of "This is why you do this." There were some attempts to make this standard algorithm more accessible. The following clip from the Animaniacs shows such an attempt.
Today's lesson is multiplication. Yakko?
Yes, Miss Flamille.
I want you to multiply 47 times 83.
Sounds like a song cue to me.
No, it doesn't.
Oh, yes, it does.
Hit it, hurry!
7 times 3 is 21, which, as you know, is just 2 tens plus 1, and so we put the 1 right here, and we carry the 2 1 left to the top of the tens place right next door, and we put it on top of the number 4, which is really 4 tens that we multiply times 3 in the ones place, and that's why we now have 12, which we add to the 2 that we carried to get 14. See how easy that was?
That clip had song, dance, and fun animation, but did it really explain the standard multiplication algorithm? How did Yakko get those numbers, and why did he place them where they did? I do not think this clip answered those questions. Under this type of instruction, I was taught to learn multiplication, but I did not understand it. We have discussed the idea of learning versus understanding a lot during our teacher preparation training. We now understand that memorization of facts or procedures without understanding often results in fragile learning. Stylianides and Stylianides argue it is important to have all three components of proficiency: conceptual understanding, factual knowledge, and procedural facility, so that our students can have true understanding of multiplication and the ability of applying their knowledge to unknown problems. This capability of using what they have learned in new and unfamiliar problems and to learn related information quickly is the ability of transfer. With support of the National Council for Teachers of Mathematics, it is my personal belief that how we teach multiplication should be a multi-step process that builds upon itself. By mastering early steps in the process, students can use the ability of transfer to grasp new steps until it can all come together. The NCTM has goals for students to work with explicit instruction in multiplication over the course of 2 years. In the 4th grade, they are introduced to the concept of multi-digit multiplication. Visual models are critical during this first year. In the 5th grade, the explanations of multiplication should deepen to refine students' understanding. I think this is key to treat multiplication instruction as a long-term process rather than a unit in a textbook. As with any mathematical procedure, the ultimate goal for our students is mastery of this standard algorithm. The standard algorithm is the fastest way to solve arithmetic operations. Fusson and Beckman defined the standard algorithm as a series of steps towards an end. How the steps are written is not in and of itself important, so minor variations are acceptable. The multiplication instruction is made up of 3 variations to the standard algorithm that lead up to complete mastery of the standard algorithm. Now we are going to turn our focus to these variations and how to actually do them. The steps of multiplication instruction are as follows: area array, which comes in basic and advanced, lattice method, partial products, and finally the standard algorithm. The basic area array is a good method for beginning students. This helps visualize the basic multiplication facts. Most importantly, It explains why, for example, 3 times 4 equals 12. This first variation helps to explain to our students why the basic facts are what they are. However, this method would be very difficult to work with for larger numbers, especially multiple digits. When our students understand their basic facts, they can move on to the next step, the advanced area array. The advanced area array helps students understand the main issue of multi-digit multiplication, what to multiply by what, and how the place values of the digits in the factors affect the place values of the partial products and eventually our ultimate product. This model helps our students understand this. The area array breaks the factors of the problems into expanded form. For example, in 23 times 8, we are able to break 23 into its expanded form, 20 plus 3. We will multiply each place value of the expanded form by 8 in our area array. For example, with 8 times 20, we have either 8 groups of 20 or 20 groups of 8, which equals 160. And then we have 3 times 8, so 8 groups of 3 or 3 groups of 8 to equal 24. We will then add up our partial products found in the cells of our area array. 160 plus 24 equals 184. Therefore, 23 times 8 equals 184. Here's another example of the advanced area array. This time, we are breaking 27 times 45 into its expanded form, 20 plus 7 times 40 plus 5. Take a minute to take a good look at the area array. You can see how we've broken down this multi-digit problem into its place values and teaching our students where all of our numbers are coming from. When you're ready to continue, press play. The lattice method is hundreds of years old and is very popular with instructional models. The lattice method almost serves as a shorthand for the area array. The lattice method helps our students understand that multi-digit multiplication is actually made up of several basic multiplication facts. It would also serve to assist our students to keep track of the place value in our partial products and the ultimate product of the problem. Watch the following demonstration video of a practice problem to learn how to do the lattice method. So the first practice problem we're going to do with the lattice method is 23 times 8. When we're working with our lattice method, we need to start by constructing our lattice or a grid. And the grid that we construct is based on how many digits are in our problem. For 23 times 8, we have a 2 by 1 digit problem, so we need to create a 2 by 1 grid. You may want to encourage your students to draw one square at a time, but I'm a fan of just doing it all in once for efficiency's sake. Feel free to pause the video at this point to catch up. The next step for our lattice is to label the sides with each digit of our problem. So we're going to put our 2 and our 3 and our 8 here. We're reinforcing place value with this method in addition to working on the next step in the multiplication process. The last step to constructing our lattice is to create a diagonal line that cuts our cell. It's important to have these extra lines hanging off the end. Feel free to pause the video to construct your own lattice. Once you finish constructing your lattice, now it's time for the multiplication part of it. What the grid does is it takes this 23 times 8 and actually breaks it into two different problems, 3 times 8 and 2 times 8. You can use your hand to block off other cells you're not working with if that helps you visually understand what you're doing. So hopefully by the area method, your students either know or can easily figure out that 3 times 8 is 24. So we need to write 24 into our cell, but we're not just going to write it here. We need to actually break up our 10s and our 1s places. So we're reinforcing place value again. So I'm going to put my 2 up here and my 4 down here. Now I move on to my next cell and I need to do 2 times 8. Again, we know 2 times 8 is 16. So I put my 10s in the upper triangle and my 1s in the lower triangle. You will do this for every single one. So we've finished with the multiplication. Feel free to pause the video now to fill in your own lattice. The last step to the lattice method is to add down our diagonals. In my personal experience, this is the step that confuses our students the most. What these diagonal lines represent is actually the place value of the whole product, not just the subproducts we've been making in our grid. So we're going to add down our diagonal. 4 is by itself, so that adds up to 4. We have 2 plus 6, which adds up to 8, and 1 is by itself, which adds to 1. Encourage your students to circle the numbers to visually separate the product from everything else you've been doing. So through the lattice method, we have determined that 23 times 8 equals 184. The next step in our multiplication instruction process is the partial products method. The partial products method is a helping step version of the standard algorithm. It will introduce the form of the standard algorithm as well as the motion of the standard algorithm. By the motion, I mean how we go about solving the standard algorithm. But instead of leaving it to be shorthand like the standard algorithm does, the partial products lays out every sub-partial product that the student would be completing, similar to the area array and the lattice method. Watch this demonstration video of 3 practice problems to learn how to do the partial products method. So when we are doing partial products, we're actually introducing what the standard algorithm of multiplication will look like. So our problem setup is actually fairly simple. That should look very familiar to anyone who's learned the standard algorithm for multiplication. But we're going to do things a little differently. A suggestion when you're getting your students started on this process, write off to the side your factors in expanded form. This will become very relevant in a minute. Another tip for beginner students, add place value lines to help them keep everything straight. Take a minute to pause the video and copy this down. So the other benefit of the partial products method is that we're introducing the range of motion that you would be mentally doing during the standard algorithm of multiplication based on how we figure out what smaller multiplication problems we will do. So we're going to first start with our ones places and we will go 8 times 3. I'm going to write that off to the side. 8 times 3. And then we're going to do 8 times 2. When you're doing the standard algorithm, you would solve 8 times 2. But because we're doing partial products, we're actually going to break it down into 8 times 20. Having the expanded form on the side helps our students remember why that's a 20 and not a 2. Take a minute to copy this down. Now that we have our multiplication problems on the side, we're going to solve them in our place value lines. So we know that 8 times 3 is 24. And we know that 8 times 20 is 160. Then we'll add it all up. Take a minute. We'll add down the place value lines. So again, using the partial products method now, we have determined that 28 times 3 equals 184. So now we're going to work on our second practice problem for partial products, 27 times 45. We're going to set it up just like we would the standard algorithm. And write it in expanded form off to the side. Again, this is just helping to serve to us and our students a friendly reminder that 27 is made up of a 20 and a 7, not a 2 and a 7. I'm going to not include the place value lines this time because this is a progression that your students should make eventually, but feel free to add them on your own if that makes you feel more comfortable. Take a minute to pause the video to set up your problem. Now that the problem is set up, we are going to determine what our sub-problems are on the side. Again, we're introducing that motion of what the standard algorithm will look like. So first we're going to do 5 times 7, so I will make a note of that on the side. Then we will do 5 times 20. Then we move over to our 4, but we know that that's not a 4, that's a 40. So we go 40 times 7. and then finally 40 times 20. Take a minute to copy that down. Now that we've done all of the prep work for our problem, we will solve our sub problems over here. So 5 times 7 is 35. 5 times 20 is 100. 40 times 7 is 280. And 40 times 20 is 800. We add it all up. 5, 11. So we know using the partial products method that 27 times 45 equals 1,215. So for our last practice problem for the partial products method, we're going to do 102 times 34. So again, we set it up just like our standard algorithm. And I'm going to write them in expanded form off to the side. I am again choosing not to add the place value lines, but please feel free to do so if that makes you or your students more comfortable. Take a minute to pause the video and set up your problem. Now that the problem is set up, we need to figure out what our sub-problems will be. So we start with our 4 times 2 and mark that on the side. There's no 10, so I'm going to skip that, so we'll go 4 times 100. Then we come over here to our 3, or as we know better, our 30 times 2. Again, there's no 10, so I'm going to skip that and go 30 times 100. Take a minute to pause the video to finish the prep work. Now we're going to solve our problems on the side. So I know 4 times 2 is 8. 4 times 100 is 400. 30 times 2 is 60. And 30 times 100 is 3,000. Take a minute to pause the video. And now our final step, we add down the place value line. So we have 8, 6, 4, and 3. So using the partial products method, we know that 102 times 34 equals 3,468. Finally, we have the multiplication standard algorithm. The 3 previous steps of our process play into the standard algorithm. The area array teaches our students where our basic facts come from, and also introduces the idea that multi-digit multiplication is made up of many basic fact multiplications. The lattice method helps to reinforce the place value within the standard algorithm. Finally, the partial products method introduces the form of the standard algorithm as well as the motions or the method of solution. Watch this demonstration video to see an example of the standard algorithm. Take a moment and we'll get started. We know 5 times 7 is 35, so I place my 5 down here and my 3 up here like that because we carried over our 30. Then we do 5 times 2, which is 10, plus our 3, which makes this 13. Then I go down a line and I put my placeholder 0. Because we've worked so much with place value, our students should be able to understand that because now we're operating with a 40, not a 4, that this placeholder is necessary. Now we do 4 times 7, which is 28, so we put 8 here and 2 up here. Then 4 times 2 is 8 plus 2 is 10. Take a moment to pause. Now our final step, we just add. So 5 plus 0 is 5. 3 plus 8 is 11. 1 down here, carry over the 10. 1 plus 1 plus 0 is 2, and 1 by itself is 1. So with the standard algorithm, we know for the third time now that 27 times 45 equals 1,215. Everything from all 4 steps of the process have come together for this streamlined, very efficient method. Finally, a quick review of the process. We want to teach our students over the course of 2 years the area array, the lattice method, the partial products, and the standard algorithm. Doing this way allows our students complete mastery over the multiplication process. Give them time to practice and learn each step before moving on to the new one. Doing this will help our students gain mastery and understanding rather than pure rote memorization. Feel free to visit any of these resources to learn more about the partial products and the lattice methods. I encourage you to learn as much as you can so that you can teach these wonderful methods to your own students. Finally, I'd like to thank these references for assisting me with my presentation, and I hope that this has been helpful to you. Thank you very much.